Hey guys, so today we're going to do a trig graph transformation overview. This is going to show all the different parts that you can change with the trig function and just the basic form and some properties of it. Okay, so here we have a basic form of every single trig function you're going to see. And as you can see, there's no trig function in it. That's just this f part. All right, here is trig function. So you could put in there, you could put in like sine, cosine, cosecant, tangent. That's where that goes. And then now let's just go part by part and explain what each one is. This A, that represents the amplitude, which controls how far up and down the graph goes from the center. And then we have this B, that has to do with period length. And the period length is equal to standard period length. So standard period length for sine and cosine, it is 2 pi, and for tangent and cotangent, it's just pi, and we divide that by the absolute value of b. And then now we have this c value, and this has to do with phase shift, which is a horizontal shift. I'll write horizontal in parentheses. That's just moving the graph along the x-axis. And the phase shift is c over b. Alright, so then we finally have this d, which is just a vertical shift. Just moving the graph up and down. And that's everything. Those are all the transformations you can have with a graph. So now we're going to do an example where we just go through and figure out all the different transformations and what they would equal. So let's say we have 5 sine, let's make it 2x, minus 3 plus 4. And let's just go part by part. First, we're going to do amplitude. Amplitude is 5 here. That's our A value. So amplitude equals 5. So that means it would go up 5 and down 5 from the center. Then second, we could do our period length. So period, we're going to just plug into our formula here. We have standard period length divided by the absolute value of b. Standard period length of a sine is 2 pi divided by absolute value of 2, which is just 2. So that's just going to equal pi, will be the new period length. And then we're going to take our c value here and use that to figure out the phase shift. I'll label it ps. And that equals c divided by b. While c, remember that the formula calls for minus c. So the c value in this case is just a positive 3. That's something a lot of people can struggle with. So it's 3 divided by b, which is just 2. So 3 divided by 2. That's our phase shift. So we moved 1.5 units to the right. Then before we have our horizontal shift, our vertical shift, which is just 4. So we went 4 units up. And those would be all the transformations, and then we would graph using all of these. And then now let's get into a different type of problem. Let's do a tangent one. So let's say, well, y equals, let's do -2 tangent. Let's have x minus 2 pi plus 1. Okay. So first thing I notice is, well, let's start with amplitude again. That's going to equal 2. Amplitude is just the number. Don't worry about the negative sign. That is actually, I didn't write this in the original part. That's an x-axis. That's like a reflection over the center line. So we'll write that out here. Reflection over the center line. So you could see that as an x-axis reflection. But the problem is that sometimes you can draw a graph, and if your center line is up at, like, let's say we had a graph here. Our center line for the graph was like up here. And then you just reflected it over the x-axis, you would have a new center line down here, and that's not right. So it's really a reflection just over this line. So if we had a point here, and then we had a negative out front, it would just go down here, if that makes any sense. So it's a reflection over the center line, or it can be seen as a reflection over the x-axis before you start adding the vertical shifts. So that's what I would do actually. I would take my standard function, so we had a sine, then make it a negative sign. I would reflect over the x-axis right there. So it would become like this. And then I would add my amplitude change and my vertical shift to just bring that graph up wherever it needed to go. Hope that made sense. Sorry if I confused you a little bit there. So what I would do is I would just make sure we do that before we do any of the amplitude or the vertical shifting. All right, so reflection over the x-axis, we'll say. And then now we're at the B point. So this is our period length. So, well, B is just 1, so we're just going to have the standard period length. So let me scroll down. So the period length is just going to be standard period length divided by the 1, which is in front. Standard period length of tangent is pi, so it's going to be pi divided by 1, which just equals pi. So nothing's changed there. And then now we're at our C value. C is the phase shift. So phase shift equals C divided by B. Remember that our formula up here calls for minus C. So the fact that it's minus 2 pi means that the C value is positive because it's just minus 2 pi. So it's 2 pi because that's our C divided by our B value, which we just said was 1. So it's 2 pi divided by 1, which equals 2 pi. And then finally we have this vertical shift. So vertical shift, we went up 1 unit. So these are all our things, and in order they would be reflection. We would want to reflect over x-axis. That would be the first thing we would do. And then you could do the amplitude change, then you could do the vertical shift, and then you could do the period and phase shift. Just know that you need to do the reflection first, then amplitude, and then finally you need to do the vertical shift. So that order is important because that'll change what your graph looks like. So thanks for watching. I hope this overview video was able to help. Here's the basic formula for all trig functions. If you can memorize this, you can just work your way through any problem pretty much. And thanks for watching.